Right. Good morning, everyone. So last week we discussed until sex determination in man, page number 8, first part in your theoretic, title by birth, female to male ratio or male to female ratio 1:1, 50-50. This is by birth in the world, males 50%, females also 50%. We discussed that last week. And today we are going to discuss about the inheritance instances of the deviation of hereditary patterns from Mendelian pattern. That means, now what are the two Mendelian patterns? Either 1:2:1 and 3:1. I mean, Mendel's first experiment and Mendel's second experiment, the results. But there are instances Mendel couldn't get this ratio, or in other words, he didn't get the expected results. So the Mendelian pattern is according to the Mendel's experiment. So this 1:2:1 genetic ratio F2 and 3:1 the phenotype ratio. So that we have already discussed these two. That is Mendel's second experiment. And the first experiment, all the organisms having the same genotype and the same phenotype, 100% tall and 100% capital T, that is Mendel's first experiment. So there are some instances, so this result or the genetic ratio, so that deviated due to these three reasons. The first one, right, due to mutations, complete this one. We are going to discuss all this one by one in detail, don't worry. Due to mutation. Actually, mutations can be gene mutation or even chromosomal mutation due to mutations. The other one due to gene linkage. And the other one due to gene linkage. Due to mutations, due to gene linkage, and the other one due to incomplete dominance. Due to incomplete dominance. So these mutations can be a chromosomal mutation due to gene mutation or DNA mutation in, that means changes that occur in the DNA or chromosome known as mutation. So if mutation occur in a single gene, we call it due to gene mutation. We are going to discuss one by one in detail. This is the last part of this lesson, and the genetic engineering we are going to complete today. So first one, what are called linked genes? Genes that are transmitted together without segregation. Genes that are transmitted together without segregation. Without segregation or separation, or genes that are linked on the same chromosome. Sometimes on the sex chromosome, gene that are linked on the sex chromosome X. Example, only on sex chromosome X. Only on sex chromosome X. You can write here example within bracket X simple H, hemophilia. So this recessive gene or this gene responsible for hemophilia link only to the sex chromosome X. That is called sex linkage. Link on the sex chromosome X. So you can write if you want sex linkage. This is also called what? Sex linkage. Sex linkage. Link on the sex chromosome X. So that is a linked gene. So I'll give one example. This hemophilia. X, simple H. Then X simple C, that is red-green color blindness. Hemophilia, the gene is because there are two sex chromosomes X and Y, but this gene is transmitted only by the sex chromosome X. It is linked only to the sex chromosome X. So that is hemophilia. What is hemophilia? Not clotting of blood. Not clotting of blood. The other one, red-green color blindness. So I write in general, so color blindness. Actually, and that also color blindness also, there are two types, complete color blindness and red-green color blindness. Here it's about red-green color blindness. So that is called, that means these genes are linked on the sex chromosome X. Then so link genes that are linked on the same chromosome to the only on the same chromosome called linked genes or gene linkage. Now this was discovered, so this bit important. Gene linkage was discovered, or linked genes discovered by, the gene linkage was discovered by Morgan, a scientist called Morgan. So it's important for your MCQs, MCQ paper. M-O-R-G-O-N, Morgan. M-O-R-G-O-N, Morgan. M capital. So now we are going to discuss about these hereditary diseases due to the this condition. That means only on the sex chromosome X I told. I'll highlight this, only on the sex chromosome X. This one. That is called sex linkage. So there are two hereditary diseases or two inherited disorders. Hereditary diseases, so inherited disorders due to the recessive gene link on the sex chromosome X. So what is the recessive gene? Simple H, that is the recessive gene. Recessive gene we represent by simple letter of the English alphabet, and this recessive gene link on the sex chromosome X. First one, right? Hemophilia. Sometimes it's called sex linkage. Hemophilia. In front of that you can write X simple H. If boy get X simple H from the mother, the son get X simple H. Baby boy gets X simple H from the mother, then boy will get the disease. So this disease is not transferred by the male. Why? Because there's no link with the Y chromosome. It is linked only on the sex chromosome X. Therefore, that's why it is transferred from the mother or from the female to the males. But females, the chance is less, because females, there are at least there's one more chance to get capital H from the father, because female get X chromosome from both mother and father. Therefore, if both side becomes simple H only the possibility, but that is not possible. Under this hemophilia we are discussing in detail symptoms and everything, how it happens, the cause and the reason, everything, right? So the second one, right, red-green color blindness. What is that? Red-green color blindness. Red-green color blindness. So what those are this is very important. Highlight that. What are the two? There actually there are four hereditary diseases: hemophilia, color blindness, thalassemia, and albinism. Out of these four, only two hereditary diseases caused due to this problem. That means due to the recessive gene link on the sex chromosome X, red-green color blindness. So we write that X simple C, the letter we use is standard letter. exam also you should better use the same symbol because it's a X simple C. If you only can assign any other symbol of the alphabet for the recessive gene. So we are going to discuss each disease separately, because in the exam they can ask MCQ or structural setup questions. Which of the following disease caused by the recessive gene link on the sex chromosome X? Or else you can get the structural setup questions. Write down a disease caused by a recessive gene attach or link only to the sex chromosome X. Then you can write one of this definitely. Okay, shall I raise the screen? Anyone still copying down? Latecomers. This one is incomplete dominance. Sometimes we call it co-dominance. But in your syllabus, they have given only the first two, gene linkage and gene mutation due to mutations. Gene linkage and mutation. Mutation can be like sudden unexpected changes in the phenotype of an organism. Because mutation that occurs in chromosomes, I mean sex chromosomes in gametes, that is definitely transferred to the next generation. So you can write if you want. I think I have not asked these mutations in detail. I think later. Shall I raise the screen? Anyone copy down? Right. Because mutations can occur without any reason also. I have not asked. Yeah, mutations I have given again separately. Then next one, hemophilia. So let's discuss what happens in hemophilia. Look at the screen. This is what happened in hemophilia. Hemophilia, it is actually the main problem is the symptom is what? If you only write in front of the symptom, continuous bleeding. Continuous bleeding even due to small injury. What is hemophilia? That means not clotting of blood. Continuous bleeding. When your skin get cut, after some time the blood get caught automatically. But here what happened? Continuous bleeding even due to a small injury or not clotting of blood. Not clotting of blood. Blood won't get clot. That's the main problem. So that means they die due to the excessive loss of blood. This disease seen only in males, and females are the carriers. Okay, right here the main cause. So this is the symptom. If you want to write here, this is the symptom. Symptom, or what we observe, the cause for this disease or the reason, right? Due to recessive gene link on the sex chromosome. Recessive gene highlight. Recessive gene highlight. What is that? Simple H, link to the sex chromosome X. Complete the two blanks. Sex chromosome X. Right. So in other words, X simple H, the main problem. Now this disease present only in males. So put a steroid. This is very, very important. You have to put a steroid separately. Hemophilia present only in males. That's very, very important. Females will never get this disease. Hemophilia present only in males. Present only in males. Only in males. That is one point. The other one you can write, females are the carriers. Females are the carriers of disease. That means females will not get the disease. Females do not get the disease, but they are the carriers. If you only write what within bracket, but they don't get the disease. But females do not get the disease. Females are the carriers, of the disease or vector, but females do not get the disease. That means hemophilia is not present in females. Very important. Do not get the disease. And males die at the birth. Males die. Males die, or they die before they become adults. Like maximum with the treatment also before they marry, before marriage. Males die before the marriage. I mean at the birth. Males die at the birth. Most of the males die at the birth. Mostly die at the birth without medication. Mostly die at the birth. Males mostly die at the birth. I'll write that in front of that within bracket. Present only in males, but they die at the birth. Even with the treatment, but they can't live for until they marry and have children. Before age 16, 18, they die. Right, then now the problem is this: what are the possible genotypes related to hemophilia? Let's see what are the possible genotypes. It's very important due to recessive gene link on the sex chromosome X. That's very important. That's why we call it sex-linked recessive gene. This is also called due to sex-linked recessive gene. Recessive gene is simple H. It is linked on the sex chromosome X. It is linked on the sex chromosome X. So I'll erase the screen. You can write here possible genotypes. Males, right? There are two possible genotypes. X, anyway, any male is XY. So XY, males XY. So males can be X capital HY, or males can be X simple HY. So X capital HY means healthy male, capital H, healthy male. No problem. He is not having the disease, as well as he will not transfer this disease to the females or males or the children. But X simple HY disease or hemophilic male. Hemophilic male. Hemophilic male. Hemophilic male, but they die at the birth. That's good. Otherwise, they will definitely transfer this to girls, because boys, no. Remember, from a male, or from the father, sons or the boys will never get the sex chromosome X from the father. Look at this. So a boy get X chromosome from the mother. This is very important. Boy get Y chromosome from the father and X chromosome from the mother. This is very important. A boy will never get X from the father. This is very, very important. Therefore, no chance father. Therefore, there's no chance a boy can get this disease from the father, because not possible. But boy can get the disease from the mother. Look at this. Boy can get the disease from the mother. How come? If mother is a carrier, or carrier female, carrier girl, and healthy father, healthy male and carrier male, X capital H Y. Now what happens? Father is not having the disease, mother also not having the disease, but she is having hidden simple H. This is the danger. Can you look at the eyes and tell whether it's capital H or capital H simple H? Don't know. By looking at, you can't look at the girl and tell whether she is a carrier girl or healthy girl. Normal girl means both capital H. If both capital H, no problem. It's very good. Why? There's no risk, no hidden gene, no hidden simple H, no hidden recessive gene. which can cause the disease. Now the problem is, if Y chromosome from the father and X simple H from the mother, what will problem will arise? Then it become X simple HY. Who got the disease? Who got the disease? Male, or the boy got the disease. Baby boy got the disease from whom? From her mother. Boy got this disease from her mother, but mother is not having the disease. Mother is a carrier. So this mother, this girl or this female has got this simple H from whom? From her grandfather or grandmother. From her grandfather or grandmother. Yes. From the grandmother definitely. So grandmother must be a carrier grandmother. How come? Because there's no chance this girl or the female, there's no chance of receiving the simple H from the grandfather. Why? No grandfathers name before they become grandfathers, they die. I told you, die. They die at the birth. Males, mostly they die. Before they marry, they will die because of excessive bleeding. Therefore, do you understand what I'm saying? This, okay, imagine mother has got this simple H from the grandmother, not from the grandfather. Grandfather X simple H will die. There are no carrier grandfathers. Remember, no carrier males. Why? Either males are healthy or die. Either capital H or simple H. Simple H die, capital H normal. But females, there are three things. Females, there are three possibilities: healthy, carriers, and disease. But this is not possible. You got the point. So the boy got the disease from the mother got the disease from the grandmother. This grandmother has got that from the great grandmother. That means mother's side this simple H is coming. Mother's side is simple H is coming. Very important. Now this family, what are the possibilities? What are the possibilities? This family, this marriage can result hemophilic boys. From this marriage, the hemophilic boy is possible. What are the other possibilities? If father gives X capital H and mother's X simple H, healthy girls also possible. Healthy girls also possible. But the most dangerous thing, carrier girls also possible. How come carrier girl? Carrier girl is X simple H. Carrier girl. Carrier girl because of mother simple H. Father is anyway capital H. To boy also capital H. To the girl also capital H. There's no chance of getting the disease from the father, and father is capital H. Father is not having a simple H. Very important. This is the hardest lesson, biology lesson out of all the biology lessons. This is the hardest one. Hardest one means like kind of little bit of maths and logic here, and not just memorizing. So if they give a healthy father married to a carrier mother, or healthy male married to a carrier female, what are the possibilities of the children? First answer, there can be healthy girls in the family. Yes, first one, healthy girls possible. Second one, carrier girls possible. There can, second answer, there can be carrier girls in the family. Then they can ask X capital HY, healthy males also possible. Why? Mother's capital H and father's Y, healthy males possible. Third one, so what are the possibilities? Capital H can combine. Capital H and simple H can combine. That is in girls. And capital Y, the boys, there are two possibilities. Y can go with capital H, X capital HY. Y can go with simple H, X simple H. So there can be in this family healthy girls, carrier girls, healthy boys, and hemophilic boys. These are the four possible children in this family. So what are the chance of having a hemophilic boy in this family? 25%. The chance, probability of having a hemophilic boy is 25%, or 1/4. 1/4 out of the 4 children, 1 can be hemophilic. So who got the disease? Males. From whom? From the females. Males get the disease from the females, but females will never get this disease. Why? Why females will never get this disease? This is the most interesting thing. To have a hemophilic girl in a family, girl get one sex chromosome from her father and the other sex chromosome from her mother. Right? This girl, hemophilic girl, disease girl, hemophilic girl, hemophilic girl. So girl has to get, because if at least one capital H is there, they don't get the disease. Right? So this one from the mother. Mother has to be a carrier. Do you get it? So did you get it? Now you can see, is this possible? Is this kind of marriage not possible? Why? Who can tell me the reason? Why this kind of marriage not possible? This kind of marriage not possible. To have a hemophilic girl in a family, father has to give simple H and mother has to give simple H, because a girl get one X chromosome from the father, the other X chromosome from the mother. Right? Girl can't get both X from the mother, because then only females will be able to have children. Okay, I'll ask the answer. Nisula, yes, Nisula, what is the reason on it?
Because the hemophilic boys die at birth.
Very good, Nisula. Yeah, very good. Okay, right. Okay, he gave the answer. Because they die before. You can search in the internet. Before they get matured, they die. So there are no hemophilic fathers in this world. Hemophilic grandfathers not possible. So since males die at the birth, most of the males they die at the birth because of bleeding. Actually, when you are born, bleeding occurs, right? I don't know, childbirth bleeding occurs from both mother and the baby, because the umbilical cord pekani they cut it, right? There can be bleeding anyway, and they take a blood also, blood grouping also, they do it. I'll ask a simple question. Is there anyone in this at this time? So how many students are there? Around more than 40 students. Today are about 10-15 students absent. Now is there anyone who has not got wounded in your, like, how many years now? You must be around 15 years old, right? Is there anyone who has never got wounded, like, tualayak? Never. Like even a small cut in the skin? Never. So you all have got wounded, right? So once at least in your lifetime. Okay, so that means, so it's very difficult to live without bleeding. I mean, so bleeding occurs. Even females, like after every 28 days menstrual cycle. So the bleeding occurs now anyway in females, but boys, no such menstrual cycle. But so by accident, maybe a small cut. So the bleeding occurs, but the blood get clot. Blood get clot, and the bleeding is not continuous. But the hemophilic people, continuous bleeding, even due to a small injury, blood won't get clot. Okay, so that's why. So anyway, they're difficult to survive. Okay, what you have to remember now? Hemophilia is caused by simple H, the recessive gene, and it is linked only to the sex chromosome X. Therefore, we call it sex linkage or linked gene. And hemophilia is present only in males. They die at the birth. And females will never get the disease. Therefore, this is not possible. Therefore, okay, I'll put across here. You can if you want, you can copy down this in your separately in your writing book. This one died at the birth. Therefore, what happened? This one is not possible. Not present. Hemophilic females not present in the world. Not present in the world. Not recorded in this world. No hemophilic. You can write the genotype X simple you can write, but they have never recorded this in the world. Okay, so I think you got the point. Similarly, you have a question to us. Earlier you raised the hand anyway. You can write females possible genotypes now. Yes, Sumala?
Sir, then that means hemophilic girls die after puberty, no?
No. There are no possibility of having a hemophilic girl in a family. That I explained to you. Because no hemophilic fathers. To have a even to give birth to a hemophilic girl, there must be hemophilic fathers. No hemophilic fathers. Before they become fathers, they die. They die at the birth. Before they marry, they die. So look at this again, leftmost side. I again displayed that. I wrote here, they die at the birth. So if they die at the birth, this kind of marriage not possible. This type of marriage never possible. Never. Therefore, there's no chance of having a hemophilic girl. No one, not puberty, even can't give birth. There's no pregnancy with this genotype. That's what I'm telling. I think you understood. If you still have a question, did you get this? Before they become fathers, they die. Ne? There can be a hemophilic male, but boy, but they die before they marry. That's the reason. Zumela, is that clear?
Clear, sir, clear.
Okay. No, right. Okay. So if they are born, then you can think then at the menstruation they die. No, before that birth even not possible. Okay, right. Now they can give different. Someday they can give in the exam hemophilic healthy male for hemophilia married to a carrier female. Write all the possible the genotypes for the children. So that's what I have done here. If you want can write down what it is. If you want can copy down this. Marriage due to marriage between healthy male and a carrier female for hemophilia. I wrote all the possible childrens they could have, right? They will give birth to these 4 types, but don't know which one will come. They can't decide. Can mother like can she think I will never transfer to any of my eggs simple H? I don't want to have any carrier girls in my family. Therefore, in all my eggs or in all my ova, I will include capital H only. Can you decide like that? Don't know which one. In Mendel's first law, independence assortment. What is this called? Separation, independent assortment, or law of segregation. So it's separated due to meiosis, and don't know which, either capital H or simple H. The 50% the chance go into the egg from the female. Therefore, actually that is not their fault. Sometimes what happens, there are diseases not seen in the father, not seen in the mother, but seen in the grandparents or great grandparents. So that is one example. Right, we'll write now the possible genotypes in female. This part is very important in the exam. They can ask questions, right? Very important. Genetic disorders due to gene linkage. So I'll write here females X capital H, X capital H. If you have any question, you can ask. You can raise hand. That is healthy, or normal female. Healthy female or healthy girl. Then X capital H and X simple H. Carrier female. Carrier female. Then X simple H, hemophilic female. Or disease female, but they die at not present. You can write it, but write here not present, not possible, not possible. It's very, very important. Hemophilic female, not present or not possible. Write it within bracket. You can write the genotype, but it's not possible. Why? Because what is the reason? Why not possible? Because to have a hemophilic female or girl in a family, father has to be hemophilic. So you can write here, for this to happen, father has to be hemophilic. For this to happen, I'm telling that so that you can understand this. For this to happen, father must be hemophilic, because girl has to get definitely one simple H from the father, the other simple H from the mother. From the mother, simple H is possible. From the father, simple H is not possible. That's why for this to happen, father must be hemophilic, but it's not possible. But before they become fathers, they die. For this to happen, father must be hemophilic, but no hemophilic fathers in the world. But no such fathers in the world. But no hemophilic fathers in the world. No hemophilic fathers in the world. Exactly. You can write that using non words and it's easy to understand, right? So to have a hemophilic girl in a family, father has to be definitely hemophilic. Remember, before they become fathers, they die. That's the reason. Before they become fathers, they die. Even with the medication, very difficult to live until age 18. That's why I think before I told you, hemophilia seen only in males, but they die at the birth. Only in males, but they die at the birth. Only males get the disease. 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 Females are the carriers. Females do not get the disease, but they act as carriers. Very important. If you can write down this using your own words, because textbook they don't explain like this. Only males get the disease. Females do not get the disease. Do not get the disease, but they are carriers. But females are carriers. Please copy down this somewhere in your tute itself or separate. I think earlier also I mentioned about this, but you better copy down this with this genotype separately in your writing book also. But females are the carriers. But females are carriers of the disease. Therefore, some countries they don't check the horoscope. Actually, they check whether there's a possibility of having children after the marriage. They do a genetic test, so we call it genetic diagnosis. Genetic diagnosis before the marriage, they can check whether there's a risk of having babies in the family with not only this hemophilia, there are many other diseases. Because imagine now this one they die at the birth, that's good. Why it is good? Sometimes it is a sin. If they die. Yeah, like if you're like, it's emotionally, yeah. But the thing is, if they live, what will happen? The next generation also will suffer from the disease. Good that they die. If it is a harmful one, a disease, if the disease is harmful, and if there's a chance of transferring that to the next generation, therefore better they die before the marriage, or they should become infertile. Even if they either infertile, that means no children in them, or they should die. So that by the nature itself that has happened, right? By the nature itself now. Yeah. So if it is a harmless one, then maybe like albinism, color blindness, then they don't die at the birth, or they can live, they can spend normal life, but disease present in both males and females. Okay, I'll erase the screen. Any questions? And did you all finish copying down this additional thing? This is one of the very interesting area in science. One of the very interesting area, genetic. You can become a genetic scientist or like a genetic engineer. So there's a separate faculty in Colombo University, molecular biotechnology and molecular biotechnology department of molecular biotechnology, that is molecular biology and biotechnology, department of molecular biology and biotechnology. I think Colombo University, University of Colombo Faculty of Science, this is a separate section, and even the medical faculty also, this is a separate section for this. Forensic department of forensic, like forensic science, right? So this is very important. You can do get specialized in this section one day if you enter university. If you are interested, you can do research, you can learn more about this. A-level biology also, there's a separate chapter for this, separate lesson. So this is the last lesson in your syllabus. Genetic, in here the lesson called inheritance, but A-level is called genetics. Jana Engineeru Vidya, in other words. Now these days we are talking about the vaccine, COVID, or you can say DNA vaccine, RNA vaccine, mRNA vaccine, Pfizer, Moderna, like all this. It links to a certain extent with this one. Right? So there you get to get the DNA fingerprint or DNA profile, PCR, right? Polymerase chain reaction. You can amplify DNA. I'll come to that under the applications, the latter part of this lesson, right? So I'll erase the screen now. Next one, because mostly the people think medicine, biology only medicine. No. There are many other interesting areas than treating the patients. Doctors means, or the medicine means, or not only the treatment, going to the hospital, and because sometimes there may be girls or the boys, they don't like to see blood, and they don't like cutting. Some they like a neurosurgeon, heart surgeon, like but they don't like to handle this. So then they can do that. There are many other options. Okay, anyway, next one, red-green color blindness. That is a second disease. What it is? Due to sex linkage. This also due to sex link recessive gene, or due to sex linkage. In other words, due to sex linkage. What is the first one due to sex linkage? Hemophilia. Now let's see, what is red-green color blindness? Inability to distinguish. What is this called? Underline here, to distinguish between, what? Red and green colors of light. Inability to distinguish, that means only red they can see. If you take a red pen or red highlighter and ask what is this color, they will tell red. If you show them green colored object, okay, they will identify that's green. But if you keep both together, best example, color light, they can't distinguish red and green together. They don't know which one is red, which one is green. Do you understand what I'm saying? Red green color blindness means some students can't see red and green. No, that is completely wrong. They can see only red, they can see only green, but red and green together they can't distinguish. They can't identify which one is red, which one is green. That means basically they can't drive vehicles. So this is not a deadly disease. This is not a deadly disease. Ratukala varnandataava. There's something called completely colorblind, right? Completely colorblind. That means they see everything black and white like the dogs and cats. That is complete color blindness. And the other one is anyway colorblind. I mean not colorblind, blind. Completely blind. That means can't see anything. Colorblind, can't see the colors at all, any color. Then red-green color blindness means inability to distinguish between red. So it's not a deadly disease. They can spend normal life, but the problem is they can't do some jobs, like certain jobs they can't do, which involves the color separation or whatever. Driving vehicles also, now long time back they didn't check the to get the vehicle driving license, they didn't do a medical test, right? Only the trial. You have to do practice and you have to do the trial, and if you pass from the trial, then they will issue the license, driving license. Now before that you have to do, I mean exam also there, but first you have to pass the exam. After that you have to undergo medical test, right? Then I don't think in Sri Lanka they check this, but they check your eyesight mainly, and that test, if you are wearing spectacles in your driving license, the photograph also, you will appear with the spectacles. So if you are driving the vehicle without the spectacles and get caught, and they check the driving license, you have photograph with the spectacles. Now you are driving the vehicle without the spectacle, then there will be a problem, right? Or else we need the doctor's recommendation. Now no need to wear anymore the spectacles, so something like that. Otherwise they can fine you. But the police officers can't, by looking at your eyes, they can't decide whether you are red-green color blindness or not. But actually the other countries, they are checking these things also. Because anyway, because in Sri Lanka they don't do it, because wasting money and all, taking time, because this is not very common, like maybe 1 out of the 100,000 population. Yeah. But in China, this is very common among Chinese, red-green color blindness. Right? Okay, so what to write now? Inability to distinguish between red and green colors of light. So I remember from this month, after the completing this lesson, most probably within from next week onwards, we'll be doing only the grade 11 work, right? Now today we are going to finish almost the grade 10 work. And reproduction lesson, there's a small part, childbirth and delivery and menstrual cycle, there's a small part to this explain. So with that, by next week we are finishing this everything, and then continuously grade 11 work, right? Okay. Then I'll write here, what is it? Inability to distinguish between red and green colors of light. Not the, I mean, light, okay, I don't know, it's like kind of optic lesson, grade 11. I'll explain about this. This some little bit of physics also under this. Right. Red. Make it simple C colors, right? Next one, what is the main cause for the red-green color blindness? Cause, so the reason for the disease. Due to what? Recessive gene link on the sex chromosome X. So right here, recessive gene we symbolize using capital. Due to recessive gene, simple C, link on what? Link to sex chromosome X. Due to a link on the sex chromosome X. Sex chromosome X. Sex chromosome X. You can write here within bracket X simple C. X simple C. So remember, these genes are not transferred by Y chromosome. Y chromosome has no connection with this, only by the sex chromosome X. That's why it all, who has this sex chromosome, only boys will get this disease mostly from the female. So this is also common among females and males, but females are the carriers. So let's see what are the possible genotypes in males. Males can have X capital C, X capital CY, healthy male, X simple CY, color blind male, healthy male, write it, please complete the blank, healthy male, and this is color blind. If you can write if you want red green color blindness, color blind male, color blind male. I use a symbol male, right? Or boys. But you can write they die at the birth. That's in the previous one. Females, you can write X capital C, X capital C, and X capital C, X simple C. What is this? Healthy or normal girl or female. This one, carrier girl. She is not having the disease, but she can transfer the disease to the next generation. By looking at the eyes, you can't tell whether she is a carrier girl or healthy girl, because you can't see whether by looking at the eyes, you can't see this girl is capital C, and this girl is simple C, capital C, simple C, this is a carrier girl. You can't look at the eyes and tell this, okay? All right. You should you have to do a genetic test, right? Then next, there's female. There's one more type, that is X capital C, X simple C, X. I'll write here. I think you have the blank, right? There's one more blank. Since some of you must be writing the other part, so therefore I'll write it here. So the other third possibility, right? X simple C, X simple C. Be careful when you're writing capital C and simple C, because in the exam we have seen marking some students we can't distinguish capital C. The patients, they can't distinguish the red and green colors, but the examiners can't distinguish capital C and simple C. Then we are struggling, then you will not get marks. Therefore in the exam when you're writing this, the genotypes, make sure so you're writing capital C and simple C clearly, otherwise that will be a problem, you will not get marks. So what is simple C? Simple C, color blind female, color blind female, color blind girl or color blind female. Understood? So right here, if you want to write here, color blindness is what? Common among males. Common among males. And females are the carriers. Why and right here, it's not a deadly disease. Both males also can get the disease, females also can get disease. But common among males, both can get the disease. Both can get it. That means both means like males and females. Both males and females can get it. Both can get it. Can get the disease. Can get the disease. But common among both can get the disease. Common among males. Females are the carriers for this also. Why I am saying that this? I'll tell you the reason. Females are carriers. Right. Because females, to have a hemophilic colorblind, okay, let's say to have a colorblind girl in a family, that means to have X simple C, X simple C. Right. Either definitely father has to be colorblind, no doubt about that. To have a colorblind girl, father has to be definitely colorblind. A girl get one capital C from the one X from the father definitely. The other X from the mother. Mother, what are the possibilities? Mother also either colorblind, or mother has to be colorblind, or mother must be a carrier. These are the two possibilities of the mother. Carrier mother or colorblind mother. So mostly this kind of marriage rare. Colorblind male married to a carrier female. If father also colorblind, mother also colorblind, all the children colorblind, no doubt about that, then also no problem, right? But imagine in a proposal, a proposed wedding, what happened? Proposal, female not having the disease, or female can be even healthy, but male is bride is not bride is not a carrier or disease one, but the groom is, I mean the boy or the male is colorblind. But they don't tell it before the marriage. They will tell this after the marriage. They will not tell. After the marriage, you will identify a colorblind child in the family. Then that can be a problem for them, like, because they will complain about this, or it can lead to a divorce case even, because without informing, they are hiding the disease. Therefore, before the marriage, I don't think you will go to the boy and ask what is this color, and what is the both colors together. You are not doing a test, right? Okay, so propose. So therefore, these things can happen. These things can happen. Now this girl has got the disease from whom? Due to the sympathy from both mother and father. But this type of marriage is not very rarely that can happen. This kind of marriage, mostly what is present? This type of marriage. I'll write that also. This type of marriage possible. Capital CY healthy male married to a carrier female. Both are not having the disease. Right? Both are not having the disease. Both not having the disease. But carrier, she is not having the disease, but she is a carrier. Then who can get the disease? Who is having the risk now in this marriage? Boy. Sons can get the disease. So from this marriage, who will get the disease? Simple C can come to the boy. Because Y anyway from the father, Y, simple C can be transferred to the boy. So you like that, you should be able to analyze. Don't know which pair they will give in the exam. Carrier mother with the healthy father, or carrier father and carrier mother, like that. Then you should be able to analyze the possible children's in that family. So you can't memorize that. You can't memorize that. Now, is there any chance of having a colorblind girl in this family? From this marriage? No chance. Why? Anyway, whatever the mother is giving to the girl, simple C or capital C, father is always giving capital C to the girl. Father's capital C. Okay. So girl will not get, even mother gives simple C to a girl, girl will not get the disease because of father's capital C. Father is anyway giving to any girl, any daughter from this marriage, father is giving capital C. Therefore, it doesn't matter mother is giving simple C or capital C, because father is anyway giving capital C to all the daughters. Mother either simple C or capital C, not a problem. Because of father, the girls will not get the disease, but boys can definitely get it if mother is giving simple C, because Y chromosome has not linked this gene is not linked with the Y chromosome. I think you understood this, right? This understanding this thing, you can't write a paragraph for this and memorize. Yes, Sumel, any question?
Are there any precautions in genetic engineering to destroy the hemophilic and colorblind genes in chromosomes?
Yes, Sumela. Now that is the new trend in biology, emerging techniques. In the future, they will I'll come to that on applications. That's called gene therapy. Genetic engineering. They can remove this disease gene or the recessive gene, and they can replace that with a good gene. That's one possibility, right? It's called genetic or gene therapy or genetic. Mostly when you hear the term engineering, you think it's max physics. No, this is genetic engineering. So you repair the genes, you introduce, you replace the weak gene with a good gene. So then sometimes in the future, like, they will find solution for it. But now actually this under research condition. In the future, they will find a solution for this. But the best thing to avoid this type of inherited disorders, the best thing to do is what? Avoid marriages among blood relatives. Right? One preventive measure for the inherited diseases or genetic diseases, what? Prevent the marriages among blood relatives. Why? Now imagine mother's side, the simple H is so simple C is coming. Mother's elder sister or younger sister or mother's side, one daughter or girl married to you. Then there's a problem. Like what is this called? In Sinhala we call it Nana Massina Vivaha. Nana Massina Vivaha. Like cousin brother or cousin sister, right? Yeah, that is not good. because the same gene, because that gene is circulating in that generation, in that family history also is there, then there's a risk of combining two of them. You understand what I'm saying? So that's why the marriages among blood relatives is not good. There's a increase it has a higher risk of blood. Now this is not happening mostly, but ancient time, even in Sri Lanka, they believed like the dowry, whatever their property, the wealth is going out of their generation of the family. Therefore that has happened, the marriages among these blood relatives, to keep their wealth and the property with that generation, with that whatever family. So therefore that has happened. But one of the main problem, not these two in Sri Lanka, the thalassemia, right? Thalassemia, blood relatives marriage, definitely you have to do that genetic test. So partners, genotypes for these diseases. Otherwise what happened, imagine now when a baby is born with such a disease, just because of the disease can you kill the baby? Not possible. So the baby also, that maybe the children's also suffering from the disease, and parents also a lot of expenditure and a lot of maintenance, and very difficult, right? So they parents also suffering from the disease, child also suffering from the disease. So therefore it's better to avoid such marriages among blood relatives, right? So that's once in the oral paper also they are this, right? One precaution to avoid to reduce the risk of genetic disorders among children. So the answer is what? Avoid the marriages among blood relatives. That was the answer, the marking scheme. So you have to remember that. But anyway, otherwise you have to do a genetic test and yeah. If you are like, if you don't want to stop that, if you want to have that marriage, then the best thing is to check blood of the both the partner for hemophilia, thalassemia and all. You can check, right? Now actually during the pregnancy period of some diseases they do it. Doctors, they do, whether there's a possibility of having a Down syndrome, because there are many others diseases also, Down syndrome, Klinefelter syndrome, Turner syndrome. They do I think after 3 months they do a 3D scan, and whether there's a, but that also not 100%, but they can check the risk of having such children's before the delivery of the baby. During the pregnancy they do this. But other countries they do, the doctor has the right to abort without informing the mother, because otherwise what happen after giving birth to the baby also suffering, parents also suffering. Therefore, like, actually it's like a killing a living thing, but organism, but it's in some countries it's illegal abortion, but some countries it's legalized. It depends on the country's law. But in Sri Lanka there are different, like but I don't have time to explain those things now. If you are doing law, okay, imagine a lawyer. That's why I told you should know something about everything. If you are good, if you are a lawyer, plus if you are good in this area, say ICT, or you have a computer science degree and you plus a lawyer, so this is a very good thing. Why? There's a big demand in the future, this money laundering, cyber crimes, then the lawyer plus a good having a PhD or a master's in IT or computer science, so then you can appear in the court. Very few lawyers in Sri Lanka. Cyber crimes, because lawyer doesn't know about IT person doesn't know law. You understand what I'm saying now? Therefore in the future, okay, if you mostly what happened, the lawyers, those who have done arts or literature and languages, they mostly, but so those who have done science, very rarely they go for law. So if you have a science degree and a law degree, it's like a superb combination. Why? You can become a forensic lawyer, right? Forensic lawyer, you can argue with the doctors. Otherwise doctors, they know science but they medicine, medical field terms, but that's why some lawyers, they do the diploma forensic medicine, forensic toxicology and all, so then you can handle the case, right? So cyber crime, cyber security, money laundering, so there's a big demand in the future for such lawyers, I think, in the future, right? This is why I'm telling you should not you should get specialized about one thing, plus you should know something about the others also. I mean, you should know something about everything in basically, right? Okay, if you know only one thing perfectly, that's not enough to survive in the future, right? With this technological revolution in the digitalization in the world. Okay, right, next one. There if you imagine, like, if you are a biologist or if you know about the environmental science plus lawyer, you can become an environmental lawyer. You can appear in the, this damage in will path or Singharaja forest. You can appear in the course and file a case because you know about the biodiversity, environmental management, wildlife management, and all this. You are good in biology as well as you are a lawyer. So you can become a lawyer, like it's a very good, right, combination. So there are many other options. That's why I'm telling, like, the people think only medicine, biology, max only engineering. No, there are so many opportunities, career opportunities, right? But anyway, you need that career guidance when you're selecting subjects for your A level one day. So anyway, whenever I get the time, I'll tell one. Right. Then thalassemia, the third disorder, genetic disorder or inherited disease, thalassemia. Actually, what is thalassemia? Okay, what are the two diseases we discussed so far? Hemophilia, not clotting of blood, caused by the recessive gene on the sex chromosome X, X simple H. Second disease we discussed, red-green color blindness, X simple C. Red-green color blindness, X simple C. Third one is this, thalassemia. Yes, Sumela, any question? Sorry.
Sir, those red-green color blindness and hemophilia dependent within the sex chromosome, no? Not autosomes,
Yes.
no?
Not, yeah, that is not by autosomal chromosome, Sumela, only by the sex chromosome X. That's why those two come under sex linkage. You can copy down that in your short notebook. You can note down. Hemophilia and red-green color blindness caused by the sex chromosome, not by the sex chromosome, the gene on the sex chromosome X. But that is called by sex chromosome X, gene on the sex chromosome X. That gene is not a dominant gene, by the recessive gene. Recessive gene, that's why simple H, not capital H. Recessive gene we represent using a simple letter, simple C, simple H. But they are attached to the sex chromosome X. But thalassemia not by the sex chromosome. How many sex chromosomes do you have? Only two, X and Y. Males XY, females XX. But there are many other chromosomes. You have 22 pairs more or 44 more chromosomes. We call them autosomal chromosomes. Autosomes or autosomal chromosomes also, there are some gene mutation. So this is one of that. Thalassemia caused by a gene mutation on autosomal chromosome. Right. Sumela, any more questions? Done, right?
No, sir, no, it's clear, sir. Yes.
Okay, right. So then, so right here, yeah, because it's good actually if at least one person is asking the question, then the others also must be having that doubt in their head. So they will also clarify that. So whenever, because if everyone is raising that, then it's also not possible. If one or two raise their hand and ask a question, the others also must be having that question in their head, and they will also clarify that doubt. Good that you asked that question, Sumela. Now, next one, thalassemia. So that is due to a mutation in a gene, responsible for the production of hemoglobin. So why hemoglobin? Hemoglobin, what is the main function? Transportation of oxygen. Then these people, they cannot carry enough oxygen, cannot transport enough oxygen. That's the main problem. Main symptom is anemia, raktaheenatawa or niraktiya. Right? Main symptom is anemia. That means normal hemoglobin can carry enough oxygen, but thalassemia patient cannot carry enough oxygen. Anemia, because due to the abnormal hemoglobin cannot transport enough oxygen, cannot transport enough oxygen. What is the main function of hemoglobin? If you want to write here, main function of hemoglobin is transportation of oxygen. Main function of hemoglobin is transportation of, if you don't write it, main function of hemoglobin is transportation of oxygen. Imagine you breathe, your lungs are working well, you breathe enough oxygen, but body fail to absorb that and transport. That means you don't have enough hemoglobin. What is the mineral, which deficiency of which mineral cause this problem? Oh, okay, who can tell me deficiency of which mineral cause anemia? Or what is the mineral necessary? What is the metal necessary for the formation of hemoglobin in your body? Yeah, Chandula. Sujivani. Mandi.
Iron.
Yeah, very good. Iron. Iron. So due to the deficiency of iron, remember when they ask questions from this lesson in the exam, they can ask questions related to the other lessons also like this. They will ask about thalassemia and then they'll ask, now this is thalassemia. Here thalassemia is not due to the iron deficiency. Yeah, iron deficiency you can overcome. You can take iron tablets or you can take food rich in iron. Okay, who can tell me a plant source rich in iron for patients suffering from anemia due to the iron deficiency? If someone is having not thalassemia, if someone is having anemia, rakta due to the iron deficiency, can you tell me a plant source? So if someone is vegetarian, how to get this iron, sufficient iron through the food? Any food rich in iron? Yes, Afan?
Beans.
Beans actually rich in protein, Afan. Beans rich in protein. I'm asking rich in iron. Nivedita?
Spinach.
Very good. Nimiti, the spinach. Nimiti rich in iron, right? Animal source rich in iron. Animal source, so those who are eating fish and meat. So, Giovanni?
The liver.
Yeah, liver. Yeah, very good. Liver. Sometimes we call it peakdu or something like the liver of the animals. Maybe chicken or pork, beef, like mostly beef they take. Beef rich in iron, but anyway, some are vegetarian. Even the red meat, in other words, we call it red meat, ratu mas, but it makes your body heaty and increase the risk of getting heart diseases if you are taking too much of this, especially pork, beef, or in saturated trans fat. Right? Okay, so that's about this anemia. So those things also they can ask, right? Only if you get a question under this in the oral paper. So you can write symptom is general peritoneal disease. Thalassemia, the main symptom is anemia, lacking enough red blood, lacking enough red blood, lacking enough red blood. Right. Next one, okay, we'll write here the, okay, wait, I have given some space here, right? We'll write that also. I have not given because there's nothing to write here X and Y, because this is not by the sex chromosome X. Therefore, we'll write all the possible genotypes here. The number one, possible genotypes for thalassemia, I'll write simple T, okay, let's write capital T, capital T. Capital T, capital T, we'll write healthy, healthy male or female, healthy male or female. Capital T is simple T, right? Carrier male or female, carrier male or carrier female. Then simple T, you can write thalassemic or disease, thalassemic male or female, right? So remember, this thalassemia is common in both males and both males and females can get it. Both males and females can get this disease. Common among both males and females. Both males and females get it, and in some district in Sri Lanka, this disease is common. I don't tell because there can be students from those district also. They are in the class. Therefore, it's not nice to tell. But anyways, in some district, if you only can search in the internet, the common the areas in Sri Lanka, the district in Sri Lanka where the thalassemia is common. So then if you are marrying someone from that those districts, you have to be very careful about there can be male also can be carrier, female also can be carrier. No, then what happen if both male and female carriers? But then it's dangerous for the children. So I'll give one example for this. Now imagine marriage like capital T simple T and capital T simple T. What happened? Mother also carrier, father also carrier. So if there's a chance, so what happened now? They are not having the disease. Mother also not having the disease, father also not having the disease, but they have a hidden gene, simple T. What happened? If the sperm contains simple T and this side also the egg also the simple T, then there's a chance of going simple T, then baby born can be male or female, thalassemic baby in the family because of the carrier parents. So that's why the marriages among blood relatives not good. If both male side as well as female side, if someone has suffered from this disease, there's a greater chance of having a child with this disease or thalassemia. Understood? You can write that in your short notebook. The main preventive measure to avoid this, to avoid such diseases, avoiding marriages among blood relatives. Next one, the fourth disease under this, albinism. Can you write here by recessive gene on autosomal chromosome? I have not mentioned here. Can you all put a stand right in front of this heading thalassemia, everyone? Recessive gene on gene mutation on autosomal chromosome. This is caused by gene mutation on autosomal chromosome. Right here, gene mutation on autosomal chromosome. Autosomes, that means somatic chromosomes. Autosomal chromosomes, not sex chromosome. Autosomal chromosomes. Please note down, that's very important. Previous one, hemophilia and red-green color blindness by the sex linkage. Link recessive gene on sex chromosome, not on the other chromosome. Never by the other chromosome, 44 chromosomes. This is by the sex chromosome. This is by the autosomal chromosome. Autosomal chromosomes. Gene mutation on autosomal chromosome. Thalassemia and the albinism both. Often any question? Nivedita? You are still writing this? Or you have a question to ask? Sumel?
Sir, that's why there's carrier male and females because in thalassemia because recessive gene at autosomes, no?
Yes, that's the reason. Yes. Yeah, both the carriers can be both males and females because they are on, or that's why I didn't write here X or Y. Yeah, capital T is capital T. It can be a male or female. Simple T, capital T, simple T. Carriers also can be both males and females. So I will give one example of here: carrier male married to a carrier female. So then this family, the healthy children are also possible. Carriers also possible. Diseased people also possible. This family, there can be children of all the types. Capital T also possible by father's capital T, mother's capital T. Then father's capital T, mother's simple T, or mother's capital T, father's simple T. Then capital T also possible. Capital T simple T also possible. Simple T also possible. Both type, both daughters and sons, so the girls and boys of all the types possible. Carrier boy, carrier girl possible. Healthy boy, healthy girl possible. Then if you only can write it, it's a good example. You can then only you learn it. You can write the marriage between carrier parents or carrier male and female possible children of this family, of this marriage. Healthy male, healthy female possible. Healthy girl or healthy boy, or else carrier girl, carrier boy. Thalassemic boy and thalassemic girl possible. So what is the chance of having actually here 1/4 this there's this one, there is a 50% the chance of having the carriers here in this family, because the capital C can arise 2 times. How capital T, capital, so heterozygous, capital T, simple T, there are 2 chances. Why? Father's capital T, mother's simple T, as well as mother's capital T, father's simple T. Capital T, simple T, and simple T, capital T. Capital T from left side, simple T from right side. And left side capital T and right side simple T. You got it? That's how you get this. And the other one is simple T, simple T. So what is the chance of probability of having thalassaemic boy or girl in this family? 25%. 25%. Or 1/4. Out of 4 children, 1 can get the thalassemia. That is why this marriage is dangerous. This is how you can get the question in the exam. They will give in the exam a question. A carrier male for thalassemia is married to a carrier female. What is the probability of chance of having what? Thalassemic boy or girl in the family. I highlighted pink the gametes. Gametes we normally we encircle. So that means all the possible gametes, because female can't tell I will include only capital T in my eggs. I don't want to have any carriers or thalassemic children in my family. You can't tell like that. Right? Either one can enter into the gamete and the sperm out of capital T and simple T. So this lesson is completely not, you can't memorize this, understand it, because they will not ask you to write an essay about thalassemia or hemophilia. They will give a question like this: carrier parents. What are the carrier parents for thalassemia? What are the possible children of this marriage? They can give essay type questions as well as structured essay type, or MCQs also they can ask. MCQ they can ask what is the probability of having thalassemic boy or girl? 25%. What is the probability of having carriers? I mean carrier girl and carrier girls and boys. 50% the chance. 2/4, 2 out of 4 children can become carriers. What is the probability of having healthy kids in this family, in this marriage? 25% or 1/4. 1/4 healthy, 1/4 or 25% disease, and 50% carriers. I hope you understood this, right? So these are all the possible, the fertilization you can have, capital T with this side capital T. The sperm capital T, egg capital T, like that. Again, capital T, the sperm, egg simple T, like that. And then simple T, simple T. This should be the other way around, capital T, simple T. Like that. I don't know whether it's clear for you. Capital T, this one, capital T and simple T here. This one, right? But sometimes the students, they mix up this also. This side they combine, right? The 2 sperms. Don't do it. They will combine capital T and simple T the same side. 2 sperms, capital T and simple T, they can combine and show they are the child. So 2 sperms cannot combine to have a baby. So it's like kind of funny answers in the exam some students write. Yes, well, any question?
Sir, probability of having a healthy children is 75% because 3 of them are having
No,
capital
Sumela. We can't tell these guys healthy. Healthy means you might tell like in general terms, so healthy means not having the disease. But here, healthy means this one, Sumela. Capital T is capital. These 2 we call them carriers. Carriers are not considered as healthy because then there must be a difference between the carriers and the capital T and capital T and capital T simple. There must be a difference. So if you are in all these 3 are healthy, then there's a problem, right? But the middle one, the 2 genotypes, carriers, we don't call them healthy. So healthy means or normal means only both are dominant. Homozygous dominant. Capital T means homozygous dominant. Dominant gene. Both are dominant genes. And the homozygous means both the genes are identical and they are dominant. If both the genes are identical and they are recessive, that is the last one. Simple T. So the middle one, we don't call it healthy. I think you understood. So the heterozygous condition, we call it carriers. We don't put them under healthy or normal, right? Yeah. Then albinism. Okay. The 4th there are only 4 diseases in your syllabus, 4 inherited disorders. 3 of them we have already discussed. This part is very important. Both these pages you can put even sex determination in man also, put 3 stars. At the beginning what you did, they don't ask much, but this is the most important part. They can raise questions in the oral paper and term test papers. Right. Shall I raise? Anyone still copy down? Please raise the hand. Shall I raise this? Did you copy down the possible genotypes with the phenotype for the thalassemia dissociated? Copy down separate, right? Right. Then next one, albinism. What is albinism? Albino. Albinism means possession of very white skin. Even the white hair, eyelashes, hair, eyebrow, everything very white, abnormal white skin. This is also due to gene mutation on autosomes. Due to gene mutation on autosomes. Due to gene mutation, write it in front of this. Due to gene mutation on, not on sex chromosome. Both these thalassemia and albinism, the problem with not on the sex chromosome, gene, recessive gene on autosomal chromosome. How many autosomal chromosomes do we have? 44 autosomes. How many autosomal chromosomes do we have? 44. That means 22 pairs. The last pair sex chromosome X and Y, 23rd pair. Right. So right here, due to a mutation of the gene mutation, due to a mutation of the gene responsible for the what? Previous one for the production of hemoglobin. This is for the production of melanin pigment. Melanin is a protein produced by your skin. Melanin protein of the skin. Melanin is a protein present in the skin. So these people have been lacking melanin in the skin. So why our skin is dark? Because of the melanin pigment. Production of melanin pigment. Actually, this is very important. It's linked with little bit of chemistry also. This melanin pigment can absorb harmful UV rays of the sun. Can you write it that additional point? Right? Melanin pigment can absorb protect the skin from harmful UV radiation. Please write it, everyone. Melanin pigment protects the skin or the cells from the harmful UV radiation. Melanin pigment of the skin, right? Melanin pigment of the skin protects the cells or the tissues from harmful UV or ultraviolet radiations. Harmful UV radiations. Now, anyone is experiencing power cut at this time? No, right? I think at this time, no one today, no power cut, right? Okay, so because now you can understand having the class early morning, right? So that also some of the days they are cutting the power cut, but anyway they have agreed not to have power cut 12 midnight until 6 a.m. now in the future. But anyway, let's see. But so therefore no disturbance for us for our theory class and the Sunday morning paper class and Saturday morning theory class, since we are doing the class early morning. So what is this? Melanin pigment present in the skin and it prevents or protect us from harmful UV. What happens if harmful UV radiations reach fair people? Higher risk from getting skin cancers. So now you have to decide whether to have fair skin or dark skin. Asians, they are struggling to make the skin fair and they apply various fairness creams, lotions to make the skin fair and to reduce the melanin. Actually, scientifically, if you look at this, it's so stupid, foolish. What? Wasting money on various cosmetics to reduce the melanin, to make the skin fair complexion. But dark skin is more healthy. So which skin is more healthy, dark skin or fair? The dark skin, dark complexion. Why? More protection from harmful UV radiations of the sun. Even not only UV radiations, imagine various sources of UV there around us. even ultraviolet light emitted by this CFL, compact fluorescent lamps, even some of the televisions or the smart devices emit UV. So even the fire. Now ozone layer also, if you want to note down these things separately in a short notebook, there's a natural mechanism of filtering harmful UV rays, like the spectacles that we are UV cut, like that. Naturally the ozone layer filter, but due to the damaging of ozone layer, if harmful UV radiations penetrate through the ozone layer, then we have the second protection from the melanin. That's why many Europeans, they wear UV protecting sunglasses. Otherwise they'll get cataract. Hey Sudha. But we don't need to wear this frequently. And Europeans, even in cricket match, you might have seen, they apply various lotions or to protect from harmful UV rays, because the skin cancer is very common among Europeans than in Asians. Some epilica. And I don't think black Africans ever apply these creams, wasting money, and they don't need to lie in the beach with to get exposed, to expose the body to strong sunlight. Africans, they have enough melanin, but Europeans, white people, they are trying to produce more melanin in their skin. That's why they are lying with minimum clothes in the beach. Why? They expose their body to sunlight. Why? Sunlight contain UV. There are two benefits you get. To produce melanin also you need sunlight, as well as to produce vitamin D in your skin also you need sunlight. You can write that. Sunlight the benefit, not only photosynthesis. So our skin also, photosynthesis, the plant leaves having the pigment chlorophyll. Our body has the pigment melanin. Both absorb something. Sunlight also absorb, chlorophyll also absorb sunlight for the photosynthesis, light energy to chemical energy transformation. In our body, melanin pigment absorb harmful UV radiation. So this is very important to understand, because that's where the ozone layer depletion, ozone depleting gases, and ultraviolet radiations, all this you learn under chemistry, but melanin you learn under biology. So there's a connection between these two. Grade 11 last chapter you learn about this. Right now, so that's something extra knowledge, not extra actually, it's you need that for your O level, about this ultraviolet radiations also. Right. Any questions? Okay. Now next one, what is the features of albino? The symptoms: abnormal white skin, white color of the skin. Next blank, complete. Abnormal white skin, very white skin. Sometimes not only humans, even animals can get this white color of the skin, even eyelashes, hair, everything. So not only humans, even animals can become albino. Example, you can write white peacock. The textbook they have given diagrams, right? White peacock, white squirrels, white elephant, white snakes. Sometimes these art apartment, various programs, they show these things. So sometimes the people think magic, like it's, how can that happen? Now you know the reason, right? So but our people, what happened, they reduce melanin, and again you have to waste time, time and money, and because first they reduce melanin to become fair, after that to protect the skin from the strong sunlight, again you have to waste money. So like this expenditure. So therefore it's better, you should better apply creams to develop melanin. No need to apply creams to produce melanin. You can stay under sunlight, right? You get both vitamin D freely, but not a very strong sunlight. You should not look at directly the sun, you will get cataract. So early morning sunlight, that's good. Example, when you're going to the school, sometimes you have the PT, or you are going to the ground for the morning assembly. So then that's good. Then next one, I will write simple, okay, possible genotypes for albinism. There's no standard letter like, but hemophilia and red-green color blindness, you have to use simple H, and color blindness you have to use simple C. But this one, there's no such standard letter. You can write, say, I will write capital A, capital A, healthy or normal, healthy male or female, healthy male or healthy female. Then capital A, simple A, right? Carrier male or female. Carrier male or female. It's present in, it's not a deadly disease, right? Present in both. Then simple A, that is albino, albino male or female. So this is not on sex chromosome, that is transferred by the autosomal chromosome. If you're right, there are 44 autosomal chromosomes, not by all 44 chromosomes. One of the autosomal chromosomes, you don't need to remember which one. One of the autosomal chromosomes, this can happen. If both simple A, from mother also simple A, from father also simple A, then there can be a chance of having albino child or baby in the family. Albino, male or female. Right. So that's about albinism. Any questions? Right. Then next one, that's all the 4 diseases. What are the 4 diseases? What are the 4 inherited disorders or genetic diseases? Hemophilia, red-green color blindness, then thalassemia and albinism. Only these 4 given in your syllabus, but there are many other. If you want to write an extra 1 point, there's a disease called sickle cell anemia. It's not given, I think, in your textbook. SICKEL, sickle cell anemia. That is called දෑකැති රක්තහීනතාව. Sickle cell anemia. There the problem is the red blood cells take the sickle shape, දෑකැත්තක් like shape. That is why we call it sickle cell anemia. දෑකැති රක්තහීනතාව. Red blood cells biconcave dish shape. Red blood cells biconcave dish shape. So then it can carry enough oxygen and it has hemoglobin. But this one cannot combine with enough oxygen. Then they also get anemia, thalassemia. Anemia, like it's like lacking enough red blood or hemoglobin. Okay, so then that's about the 4 diseases. Next one, mutations. Right? Mutations. Now in single we call it vikurti. Right? Mutation. So mutation can occur due to 2 reasons. There are many reasons for mutation. Okay, we'll write here. I'll finish this also, then this part is done. Mutation means sudden changes in the phenotype of an organism due to the changing of the structure of DNA, due to the changing of the structure of DNA, or due to the changing of the number of chromosomes. Right here, sudden changes of the phenotype of an organism, sudden changes of the phenotype. Phenotype means appearance. Because we can't see the genes through our naked eye, what we observe is what is expressed to the outside called phenotype. What is expressed to the outside due to the genes called phenotype. Sudden changes of the phenotype of an organism due to the changing of the DNA. Due to changing of DNA, the structure of DNA, or due to the changing of the number of chromosomes. DNA is damaged, or part of the DNA is erased, then the vital genes are missing. Changing of DNA, or changing of the number of chromosomes. Changing of number of chromosomes. We call it chromosomal mutation. If number of chromosomes changes, so it's chromosomal mutation. Chromosomal mutation. I'll write here the other line. Due to the changing of the number of chromosomes means, in other words, more than 4. In case of humans, more than 46, or less than 46. So normally we have 46. It become more than 46 or less than 46, so maybe 45 chromosomes. It's a chromosomal mutation. Or more than 46, that means 47 chromosomes. So then it's chromosomal mutation. That can have, say, example, one of the best example, Down syndrome, Turner syndrome. Some mutations are harmless, not deadly. Right? If the mutation can be good or bad, some mutations good. So then that will appearance again and again because people like it, right? Then there will be more reproduction with these people. most of the people get attracted, even animals, to that mutation, harmless mutation. Many females get attracted to that male. What happened then? Next generation there will be more children of that type. You understand what I'm saying now? That mutation is good, but the good adaptation for their survival. But some mutations are harmful, then they die, or that will not be seen easily. So these are called chromosomal mutation. Chromosomal mutation. Chromosomal mutation. This is due to the changing of the DNA or the genes, called gene mutation. So gene mutation means, actually you have, I don't have time now, the DNA part, you get the genes in your DNA, right? You should know this also. We have the nucleus in the cell. Cell contain a nucleus. Cell contain nucleus. Inside the nucleus you get chromosomes. Chromosomes. In chromosomes you get what? DNA. Inside the chromosomes you get DNA. In DNA you get genes. Is that clear? So it's not visible to our naked eye, right? It's not visible. Even one cell is not visible to our naked eye. Then how can see the nucleus? If nucleus is not visible to our naked eye, how can we visualize chromosomes through our naked eye? If chromosomes not visible, DNA not visible. If DNA not visible to our naked eye, genes also not visible. But through the electron microscope you can see them. Right? Through the electron microscope you can visualize them and you can magnify. So that's why if there's a little bit of DNA, then you can do PCR test. What is called polymerase chain reaction. You can amplify DNA. So PCR is used to amplify DNA. So example, you get the coronavirus, COVID-19 virus contain either DNA or RNA. Maybe only few viruses will get extracted to the cotton swab. Then what happens? They do the extraction and then they go for the PCR, because directly from the sample they can't see this DNA enough. That's not sufficient DNA. So they amplify that DNA and check whether it has come from the virus or not. So when they amplify, they can detect it. If they detect, then they will tell your PCR is positive. What happened? During the sample collection, this DNA can get destroyed. During the transport, DNA can get destroyed, can get damaged, can be by microorganisms can attack the sample. Then your PCR can be negative. So there are some cases like that also. Sometimes actually that person is having the COVID, but PCR is negative. There are some instances. That is because of not handling the sample properly and not transfer. Not the storage condition also matters. Right, okay, shall I erase the screen? So mutation occur in a single gene known as gene mutation. That also you can put a stand, right? Mutation that occur in a single gene is known as gene mutation. Mutation that occur in a single gene called gene mutation. Mutation that occur in a single gene is known as gene mutation. Jana Vikruti, gene mutation. Gene mutation. So remember when this happened in sex chromosomes, or maybe like the sex cells or the gametes, mutation that occur in a gamete is always inherited. Now imagine if someone smoke and get a lung cancer or mouth cancer, that is not inherited, because you are not going to transfer the cells to your children from your lungs or the mouth. You understand what I'm saying? You are going to transfer the cells to the next generation from your testes and the ovaries. Testis, the sperm cell or the sex cell, male sex cell, and from the ovaries, the female sex cell. So then the next generation can get it, right? So imagine you face an accident and there's a big, the scar or like something, wound. So that is not transferred to the children. Therefore, changes that occur in the chromosomes of the DNA of the somatic cells not transferred to the next generation. Any damage caused to the DNA or the chromosomes of these gamete cells, if you could better write this in a short notebook. Any change or the damage caused to the DNA or the genes of the sex chromosomes. What is not sex? Sorry, the gamete cells. Any change or the damage caused to the DNA or the chromosomes of the sex cells, so the gamete cells, are inherited. That means that's why nuclear weapons, nuclear bombs, radiations, subjecting the testis to radiation, subjecting the ovaries of the female to radiation or the harmful, what is called, chemicals. Then there can be a change in the DNA of the gamete cell or the sperm. Then the next generation will suffer from the disease. That's why nuclear weapons, nuclear bombs not allowed during any war. It's like it's like war crimes. It's illegal. It's not. It's like it's banned, right? Use nuclear stuff, and even your mobile phone keeping inside the male especially pocket not good because radiations. So your testes get exposed to more radiation. That's why there are so many pain receptors around the testes of males. I think you males, you know about that, right? Example, cricket match, they put a guard, right? Otherwise, what happen if the leather ball hits the testis? What happen? They'll faint on the spot. Even in wrestling, boxing, what they can't punch the testis. There are so many pain receptors. You have to protect it because that is the gene pool for the next generation in the testis, the sperms stored in the epididymis, right? In ovaries also same thing. So they are. That's why whoever created, like the creator, has put many pain receptors in the skin around the testis. So that is good for the girls, for the defense mechanism. In case for their safety, they can punch the testis of the female. They will get fainted on the spot, right? If you punch this, even there are so many pain receptors, right? That's why like it's I mean in wrestling and all, they can't punch the testis, so they will stop the game, right? Because that is any change that occur because exposure to the sperms or the eggs or ova to the radiations even during the pregnancy period. Mother's wombs, if subjected to X-rays, gamma rays, nuclear radiations, so then the baby born, I think best example you all learn, right? The Second World War, the Hiroshima, like, so from generation to like generations suffered from that. So many generations suffered from this because directly the radiations can damage the DNA or the genes because gamma rays can penetrate through the body, through the cells, and can damage the nucleus, the chromosomes inside the nucleus. That's the reason. Then next one, the main reasons for the mutation. So what are the main reasons for the mutation? One reason, right, due to the exposure to harmful radiations. Due to harmful, right? Number one, due to harmful radiations. Due to harmful radiations. Like example, you can write nuclear radiations. Due to harmful radiations. Example, you can write gamma rays or X-rays. That's why, have you all seen the X-ray room in the hospital? They don't allow the visitors to stay inside the X-ray room. Only the patient they take in. Right? Even around the X-ray room, they put that radiation symbol. Even in airport and the harbor, the custom officers, they use this some radiations to detect illegal stuff or whatever, to detect, even the check in the luggage or whatever, the bags, they use this. So therefore, some they don't like it because they also get exposed to, the officers also get exposed to those radiations, gamma rays, even alpha rays, beta rays, ionizing radiations. That's why when you buy a mobile phone or smartphone, you have to check whether it's TRC approved. What is TRC? Telecom Regulatory Commission. Regulatory Commission. So if it is not TRC approved, that sometimes harmful radiations might emit that mobile phone. So that can be harmful to your brain because you are keeping the phone close to your brain. And if you are sleeping, keeping the mobile phone under your pillow, that's not good. Radiation level is high around your brain. So you can end up with a brain tumor even, right? So due to the exposure, so radiation is not good. Right? But anyway, that they keep the radiation like the low energy, this radio frequency and wireless communication. Number 2, harmful radiation. Next one, there's a nuclear weapons or nuclear power station. Any accidents caused in the nuclear power station, that is the danger. Any accidents, nuclear missiles, nuclear weapons, or the Russia, Ukraine, so the war, if they use nuclear things, so this will be like disaster, right? So we can't stop. The next generation also will suffer from that. Then number 2, due to harmful chemicals, due to the exposure to harmful chemicals, due to the exposure to harmful chemicals, can result mutation. Number 3. Now actually mutate. Okay, not number 3. You can put here. You can put a stand right. Mutations can occur without any external influence, spontaneously. Mutations can also occur. Don't know the reason. Sometimes the mother also no issues, father also genetically no problem, healthy parents, and they are not exposed to radiation, but child born having a mutation. So that is by the we call it karumeo, like different reasons, religious wise, Buddhist they is like can't help. That's by the nature itself. Mutation can occur by the nature itself, or mutation can occur without any external influence. Without external influence. By the nature itself, without external influence. One more thing you can write here, mutations can be harmful or harmless. Mutation can be harmful or harmless. Example, this albinism also due to gene mutation, right? Albinism also due to gene mutation, but it's not a very harmful mutation. But if you take hemophilia, that is a harmful mutation. Mutation can be. Now you can start. You can think now. When a mutation occurs in one generation, so that can be transferred again and again. Then it become a disease. Everyone will learn like this, right? So then it will appear again and again in the generation. Then it become a registered disease, right? Mutation can be harmful. So some harmful mutations, mostly they die. That's good. Harmful or harmless. And the other one more thing you can write here, mutations that occurs in the gametes always transferred to the next generation. You can write that also. Mutations that occur in the gamete cells are always transferred to the next generation. Mutations that occur in gamete cells, so the sex cells are always transmitted in sex cells or gamete cells. Sex cells, or you can write here gamete cells, are always transmitted to the next generation. If there's a mutation in the sex cell or sperm or egg, definitely it will be transferred to the next generation. But if there's a sudden change in the DNA of the chromosomes of your facial muscles, or the mouth or the lungs or any part of your body other than in the sex cells, it will not be transferred to the next generation. But gamete cells, yes, are transferred to the next generation. Transferred to offsprings. Offsprings means next generation, children's. Copy down that also. Remember this lesson, actually when you are learning a lesson like this, so maybe some of you are not doing LL bioscience, some of you are doing LL arts and commerce, then that is the end of your science. From OL you stop your science. So then at least not only for the exam, for your general knowledge, for your common understanding, these lessons are really important. Otherwise you will, after marriage you have to see a doctor and ask these things. So you have some basic understanding, that's good. As citizens, scientific literacy, when we are talking about the technological literacy, IT literacy, so like that, that's the most important thing is scientific literacy, vidyatmaka saksharatava. So therefore you should do this with the intention of improving your scientific knowledge, with the intention of improving your genetic this knowledge about this area. So then the subject will be interested, and you will be more knowledgeable sometimes than the teachers. You explore this more, so due to your curiosity. So that is the most important thing. Right, it's almost 8 o'clock now, 8:03. So genetic engineering, the last part, molecular biotechnology, that part like about half an hour work, but it's very interesting part. That also I will do that next day. With that we are going to continue the grade 11 work also from next week, right? So we'll stop for today. So this part very interesting. There are some pictures also. I don't know whether you watch this we call it what is this the rape case, how to detect the suspect and all. This from beady birds and cigarette birds, how to detect the people, how to identify the suspect. So that part we will be discussing next week, right? So then we'll stop for today. Have a good day and God bless you.